So in this presentation we're going to look at the Pareto distribution, in particular the Pareto type 2 distribution. This is also known as the Lomax distribution in case you're trying to look it up and wondering why things don't reconcile with what you read in books, because you might be looking at the type 1 distribution in error. So what we might sort of look for is alpha and lambda, the shape parameter and the scale parameter respectively. In this question, we're going to let them equal to 2 and 3 respectively. So the question really is, define the median of a Pareto type 2 distribution with parameters alpha and lambda, and we're letting those equal to 2 and 3. Comment on the skewness of this distribution. Okay. So here's all the key components of the Pareto type 2 distribution, and you sort of can look these up in books. Now, the thing about this is, actually, what we're going to do is base ourselves off this part here, the CDF. Okay, and the question asks us is to derive the median. Now, so essentially I'm just going to show how we go from the median to the CDF, the cumulative distribution function, to the median. Now we'll also note the mean there later on in the second question as well. We'll use that for the second question. The mean is undefined for alpha less than or equal. Let me just actually fix that there, just to sort of highlight the fact that this is the alpha root, if the alpha root of 2 minus 1. Okay, so there's a little alpha in that square root notation there. Bit of a clunky way to express it. Also, just actually to note that there are two ways of specifying the CDF. Now, this is what you would sort of see in books, this one here. But I actually think this second approach here is easier to follow what's going on. So what I'm going to do is use that one there. Okay? This one here. So that's the probability of x less than a certain value. Some value small x. Okay? So that's what we're going to use. So the first question is about the median. So the median is what we're going to denote here as m. Now the thing about the median is that the probability of x less than or equal to m is equal to 0.5. Okay, and this is the form of the CDF that we're going to use, the cumulative distribution function. Okay, and so what we're going to do here is rearrange that. So if that is equal to 1/2, okay, necessarily, so it's 1 minus this term here is equal to 1/2. That means that this expression here is also equal to 1/2. Now I'm going to let x equal to m here. Okay, so essentially what I'm going to do is just quickly replace this value of x with an m. Okay, so what we're going to try and do is just algebraically rearrange it into this expression here. It just takes a moment or two. So just to be clear, that is 2 to the power of 1 over alpha minus 1, and that is pre-multiplied by lambda. That is our value of the median. Now, previously we were told that alpha is equal to 2 and lambda is equal to 3. So what we get here is this expression here. I just have to scroll down a little bit. Just sub in the values there. 2 to the power, 2 times the square root of 2 minus 1, okay, and that turns out to be 1.2426. Using the expression previously for the median, which was lambda divided by alpha minus 1, that simply works out to be 3, okay. So this is from the tables that you can use, this expression here, and remember alpha is greater than 1. So this is our value for lambda, our value for the median. This is our value for the mean. So it essentially has a positive skew. The mean is greater than median. And just as a quick remark, you probably find that that is common for most, pretty much common for the Pareto distribution. All right, we'll leave it there. That's grand. Nice one to get started with.